like that, okay? All right. Now, um, let's talk about classification of matter. So guys, again, matter is something that is built of some mass, so something that has atoms in it. And depending on how you combine those atoms, you make the classification for matter. So the two broad classification for matter is pure and mixture. We'll come back to mixture later. We'll first talk about matter. So guys, about the pure matter. So guys, pure matter means what? That there's going to be a singular thing in a container. Okay, so pure can further be classified into element and compound. Guys, first I'm going to complete the classification and then we'll come back to these and do the examples. Now the elements can further be classified into two different categories. Elements can be atomic and they can be molecular. Now compounds are also two type. They can be molecular again. Do you see? You can have molecular compound. You can also have molecular element. So you must always make sure to specify that you have molecular element or molecular compound. Then you have ionic compound. Okay. Now, guys, molecular is also called covalent. So they are also called covalent compounds. Okay. Now, let's go back to elements and compounds. Okay. So let's take some examples and we're going to see what do we actually mean by each one. So, guys, element is when you have only one kind of atom, uh, and that's what something is made up of. So, for example, the oxygen that you're breathing in, what is the formula of that oxygen that we breathe in? The formula for oxygen is O2. And what is the formula of the gas that we breathe out? It's called CO2. Do you see that oxygen is made up of only oxygen? Only O, so one oxygen connected to another oxygen? Whereas when I come to CO2, this carbon dioxide is actually made up by a combination of carbon and oxygen. So it's like this. So CO2 looks like this. CO2 has carbon in the center and oxygens next to it. So in CO2, it's made up of multiple things. It's made up of carbon atom and it's made up of oxygen atom. So two different elements combine to make CO2. So when you combine two different elements, that's called a compound. So compound, remember guys, is made by combination. So very similar words to here, compound, combination. Elements, on the other hand, are made up of single element. So single type of element, okay? And here for compounds is by combination of different elements. So CO2 is the example of compound and oxygen, O2, is the example of element. But element does not always have to be paired up. Like you see this O2, there's two oxygens. When we say, guys, graphite or diamond, they're made up of carbons. They're actually made up of carbons, singular carbon. So a carbon is not bound, is not bonded to another carbon. You just have carbon atoms, which just come together and they make graphite or coal or diamond. Okay, so when you have that case, you call them atomic element. When you have just, of course, you only have carbon in there, but that carbon is singular. I mean, that carbon will have, so it will be making networks. I'm not saying it's going to be one isolated carbon. What I'm trying to say is there are going to be multiple carbons surrounded by other carbons, but they're not holding on to each other. They don't make a covalent or ionic bond. Okay, they do stick together, but not with the covalent or ionic bond. Okay, so atomic elements are when you have singular atoms. Molecular element is when you have O2 or N2 or F2, Cl2, H2 or P6 or P8 or or sulfur 6. Okay, so when you take different atoms and you combine them, guys, C is different from O2 is because here O2 means what? O2 means one oxygen bonded to another oxygen, and then of course you can have lots of them in the container. So let's have a container filled with oxygen. So there's going to be lots of O2 present in the container. So this container is still pure in the sense that there's only O2 in there, but it's made up of oxygens connected to each other, but a lot of them. So this is what an oxygen cylinder is going to look like. So that is a molecular element. Now, molecular compound, the example for that, guys, is CO2. Do you see when you combine two different atoms like carbon and oxygen, when you combine two different elements and you make a combination, that's a compound. And you're making a molecular compound. Why is this molecular compound, guys? See, there are two types of compounds, covalent and ionic. These are actually also two types of bonds that are made. So guys, covalent compounds are the compounds that are made by a combination of non-metal plus a non-metal. And ionic compounds are made up by a combination of metal plus non-metal. So for this, we need the periodic table. So let's see, guys, CO2. Where is that on the periodic table? On the periodic table, you got CO2. Carbon is this. It's blue. So it's a non-metal. It's on the right-hand side of the staircase. And then you have oxygen, which is also on the right-hand side of the staircase. So as we learned, guys, all this region here, not including these yellow, golden metalloids. So these atoms, the blue in color, all of these are non-metals. So if carbon, oxygen both are non-metal and they combine, you call them covalent compound. Okay. Now, if you have a metal and non-metal, so let me give you an example of NaCl. Okay. So let's look at NaCl. So Na is sitting right here. This is sodium. Sodium is a metal. And then you have Cl, chlorine, non-metal. So if you take a metal and a non-metal and you combine them, you make ionic compounds. Okay, so sodium chloride or MgCl2, magnesium chloride, okay, or calcium oxide, calcium metal, oxygen non-metal, magnesium metal, chlorine non-metal. When you have them, those are ionic compounds. So, guys, you're going to be seeing quite a few questions on this on the exam where I'll give you examples and ask you what are they. So, for example, if I ask you NH3, where will you put this? First of all, let's answer the question. NH3 is an element or a compound. It is a compound. Why? Because it's made up of two different elements. It's made up of nitrogen and hydrogen. So it's a compound. It's made by a combination of different elements. Is it ionic or molecular? And molecular is also called covalent. So is it molecular covalent or ionic? For that, we need to look at if N and H are metal or non-metal. Now let's look at that, guys. Nitrogen is sitting here, which of course is a non-metal. Now you can look at for hydrogen and you can see hydrogen is sitting here. It's on the left-hand side of that staircase. So shouldn't this be called shouldn't this be called a metal? Because we learned that things on the left-hand side of the periodic table are supposed to be metals. Yes, we learned it right. But guys, the thing here is that hydrogen, since it only has one electron, we like to keep it here in the first group. We'll learn about that later on. But you see it's marked blue. It is actually an exception. This is a non-metal. The exception that it's sitting on the left-hand side and still a non-metal. So on the left-hand side of the staircase, everything is metal except hydrogen. It is non-metal. So when we say NH3, so N was right here, which was a non-metal, and H is also non-metal. If you have two non-metals, what do you call that? You call that molecular. You can also use the term covalent, and that's also okay. So you can call this covalent compound or molecular compound. Both are acceptable. Okay, so guys, that's what your exam questions will look like. Okay, now when it comes to the mixtures, let me finish with the classification of the matter. So guys, we learned pure already. Now let's quickly talk about mixtures. So guys, mixtures are also two type. And first of all, the definition of mixtures, when you have two different compounds or elements. So when you combine element with another element or a compound with another compound, those are called mixtures. Okay, so if I take, let's say, oxygen and CO2 and I combine them in one container, then that is going to be a mixture because you do not have oxygen. So you see oxygen and carbon dioxide both in the same cylinder. You cannot call that oxygen cylinder. You cannot call that CO2 cylinder. It's a oxygen and CO2 mixture cylinder. So there can be classified, guys, as homogeneous and heterogeneous. So homogeneous is, guys, when everything is soluble and you have a consistent mixture, okay? It's evenly spread out. So if I give you an example, guys, if you take NaCl, salt, and you put it into water, or you take sugar and you put it into water and you mix properly, okay? Then you're going to see that the salt or the sugar in the water is going to disappear. You won't be able to differentiate it from pure water. Of course, I'm saying when you mix it properly. I'm not saying sugar sitting in the bottom, salt sitting in the bottom. If they're evenly distributed and these things are soluble in water, they're homogeneous. Okay. Let's say you're trying to make smoothie. You put all the fruits, you put it in a shaker, and you make a smoothie, and it's all good. And it's the ideal smoothie that you actually wish you could always make, which is where the sip that you take from the top is same as the sip you take in the bottom, and tastes the same. Uh, that is going to be a homogeneous solution. On the other hand, guys, if you take a fruit salad, in fruit salad, you guys know that you have different fruits. So you got apple, oranges, watermelon, or mangoes, or any fruit that you're going to cut and make a fruit salad. It is a mixture because it's not just apple or it's not just orange. It's a combination of different fruits, but you can take out each single fruit separate from another fruit. So that is heterogeneous. So another example is when you take sand and water. If you combine sand and water, guys, and you mix them, as much as you mix it, the sand will come down to the bottom. It's not going to disappear. If you're going to take a sample from the top of the sand mixture, it's going to have different amount of sand, and you take a sample from the very bottom of the mixture, it's going to have more sand, of course. So that is heterogeneous mixture, guys. So again, the definition of mixtures when you combine elements and compounds, one element with another element. So I can combine oxygen and nitrogen and call it a mixture, okay? And I can have, so let me ask you here, if I have CO2 gas in a cylinder, are you gonna call that a mixture or is that pure? This thing is pure because it only is CO2. I know it's made by a combination of carbon and oxygen, that's why it's a compound, and it's a covalent compound because both are nonmetals, but it's still pure. It's not a mixture. It's only made up of CO2. Okay, but if I take CO2 and oxygen both in a cylinder, that is going to be a mixture. And if they're evenly spread out in a mixture, then this is going to be a homogeneous mixture. Okay, all right. Now, the very last thing that I wanted to mention here, guys, is the rule of 7. Okay. Now you must be wondering, okay, here when we say molecular elements, you see oxygen is paired up, nitrogen is paired up, F is F2, Cl2, H2, and then the other ones, there are 8 of them together or 6 of them together. You see these here, they're two atoms, they're diatomic. So which atoms do we already know are always diatomic on the periodic table, guys? This is going to be important. So we can tell that from the periodic table. We're going to learn what we call rule of 7, okay? So rule of 7, what does it say? So I'm going to mark 7 things on the periodic table, and they're going to make a 7 on the periodic table, okay? So I'm going to mark 1, And then let me tell you where, if you forget where to start, start at number 7. You see this is 7. There are going to be lots of 7 in rule of 7, okay? So nitrogen starts at number 7, so I'm going to label this one. Then I'm going to go next, and then I'm going to go next, and then I'm going to go down and form a 7 on the periodic table. Okay, you see this looks like a 7 if I connect all these dots. So how many atoms do I have right now? 1, 2, 3, 4, 5, 6, and then the 7th one is sitting here, this hydrogen. Okay, again guys, you're making a 7 on the periodic table. You start at number 7, and there are 7 of them, including the hydrogen. All of these atoms like to be diatomic. So if I ask you, this O is present like what in nature? It's present like O2. F like F2, Cl like Cl2, Br like Br2, I like I2, N like N2, and H like H2. That's how you naturally find them in the nature. You cannot just find N in nature. You cannot just find O in nature or Cl in nature. They're always diatomic. So guys, I'm going to be ending today's lecture here, and then we'll see you guys in the next lecture. All right, have a good day, guys.